Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online with all of our old shows at www.rce-cast.com. I also, again, have Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks again.
Sure, Brock. Always good to be here. Like I say, almost every episode, this is I get to learn fun new stuff. And today we're actually talking to a partner of Cisco, so this is good stuff here. And also got to feel obligated by my corporate overlords to mention my blog out there on blogs.cisco.com, and I think it's linked to from rcecast.com as well.
Yes, and so our guests today are going to be talking about Zenoss, a monitoring system, but we have two guests. We have Simon Jakesch, who's a principal engineer on the project, and then we also have Randal Rheinheimer, who is at Los Alamos, who has adapted Zenoss for use in an HPC environment. So guys, welcome to the show, and take a moment to introduce yourselves.
Hi, this is Randal Rheinheimer. I'm the Deputy Group Leader of the HPC Support Group here at Los Alamos. We have about 60 people and 2.5 petaflops or something like that of HPC on our force. And a couple of years ago, we took Zenoss as a great starting point for a monitoring solution that we needed, and adapted the standard software to do HPC. So that's where I fit in.
Yeah, and hello everybody. This is Simon. I work for Zenoss, and I've been with the company since the very beginning. And I'm basically responsible for assisting, large customers, tricky installations, features, basically everything that needs somebody to get stuff done. Other way of thinking of me as a Swiss Army knife, basically.
Okay, well, why don't one of you explain exactly what Zenoss is? I think it's kind of came out a little bit, but what's kind of its overview and what's it aimed to do?
Yeah, so I'll take that question. Zenoss is basically we call ourselves a cloud monitoring solution. It's a distributed monitoring solution that allows you to dramatically scale and monitor all aspects of your infrastructure or data center or cloud, whichever term you prefer.
So what's a little bit of the background of Zenoss? I've seen it pop up a number of places. It seems like you guys have been growing. Where did it come from?
It was originally developed in some of the first kind of software as a service type of environments that were probably around back in 2003. It was started by a gentleman called Eric Dahl. He basically was kind of using a traditional set of software tools to monitor and manage their infrastructure back then, and he just kind of grew sick of the big wieldy systems that they had, and very expensive systems. So he just started to set out and basically write Zenoss. Nowadays, we then turned into an open source project that basically now has spread around the globe. We have installations in all 7 continents. We're somewhere in like 120 different countries, and have installations right around the 12 to 15,000 mark that literally call home every day, basically. So yeah.
So what kind of things does Zenoss monitor? So, hardware, software, infrastructure, what can you watch?
Basically, Zenoss really is the idea of Zenoss is to provide you a unified management solution. So it really has the ability to watch essentially everything that you can imagine. We watch everything from the very hardware details of your blade and universal power supplies to the transactions that your Apache and your web server are basically, or your queuing server or your middleware server are basically performing. So really the entire stack, the idea is that we basically provide you a holistic view that allows you to look at everything anywhere inside your data center.
Now, it is my understanding, too, that you're also a partner with Cisco. I haven't been involved personally in your work, but I see that you can also directly monitor Cisco's line of servers, the whole UCS line. So could you tell us a little bit about that?
Yeah, sure. So about 1.5 years ago, Cisco was kind of on the verge of really pushing and starting to push Cisco UCS. We've already had support for VMware, and we kind of found UCS to be really doing essentially the exact same thing for hardware that VMware did for the OS, right? So really abstracting away the hardware, and since we've had support for VMware, the logical conclusion was really to then take the next step and essentially add support for the perfect software, right? So the perfect VMware hardware combination, essentially. And so we basically added in, because Cisco was basically smart enough to add a very good API from the very beginning. We basically tied into that API, and we can now basically give you an entire view of your UCS stack, meaning, we discover all your blades, all your chassis, all your service profiles, and then we can actually tell you which VMware host of which hardware host is, or which operating system is running inside your host. So we can really give you a holistic view of business to blade, essentially, right? So from the very chassis up to what's running, which application is actually depending on that chassis.
So what's the architecture of Zenoss look like if I get it and I set it up on a box? Where do I go from there, and what do I see?
Yeah, so setup is really easy. We really try to cater to obviously, there's a lot of open source tools available in the market in that space. What we've really found is that a lot of them are wieldy and difficult to deal with. What we try to do is make the entry as easy as possible. So really, I always say, I want my grandma to be able to use the software. And really, we make it very easy. You can download a VMware image. You can download an ISO image. You can download RPMs. You can essentially fire up the VMware image on your desktop. It starts up the application and provides a web interface. When the web interface is provided to you, you have the ability to add devices. It simply asks you for the type of device, be it a Linux server, be it a UCS chassis or manager, be it a VMware virtual center instance, be it a network device, and then it asks you for credentials and the protocol to use to actually discover and monitor the device. You can get a system going within virtually minutes, essentially, and from that point, you can then just grow. There's obviously methods of auto-discovering your infrastructure, methods of automatically loading spreadsheets of your infrastructure into the system, and then once you get the system started, we really want everything to work automatically. So after you giving us the details of your devices and kind of entering the specifics of them, we basically automatically discover and what we call model your environment and create a kind of a view, so we can actually see the interfaces and file systems, and we can process the events coming from the various logs and so on and so forth.
So this is maybe where HPC and LANL comes in, because our architecture as we use Zenoss is different from Zenoss as designed. We stumbled across Zenoss really a couple of years ago, looking at some of these unwieldy and expensive solutions that Simon referred to in about 2007, trying to find a basis on which we could build an HPC monitoring system. And the things that we liked about Zenoss were the community model, the initial architecture itself, the model of the system that sits sort of in the middle of Zenoss. But we also recognized that there were differences between a data center, say a web farm kind of place, and HPC. And so one of the architectural differences, one of the architectural modifications that we made is we made a hierarchical system. So where Zenoss as designed and as deployed is, sort of a single flat thing, Zenoss HPC, which is, Simon can talk about this, but it's our contribution